Hello math enthusiasts, welcome to definition 1. What is the sigma algebra? Why that is important? Because we gonna to studying advanced probability or functional analysis. This is so important, notice. Okay, without any further ado, let's get started. The sigma algebra is a collection of subsets of omega such that following these properties. At the first, omega must be a member of this subset, and also if you consider a member like A in the F, a complement belongs to sigma algebra. And the third properties is if A1, A2 and also all these member, if in sigma algebra the union of these member also must be in sigma algebra. We say this note in mathematics a countable union of member. Therefore, is closed under countable union. These properties, if be in any subset of omega, we say this subset is sigma algebra. For example, in this question, you consider your omega is 1 and 2, and this subset, let's calculate that is sigma algebra or not. At the first, omega is in the subset. Yes, the one property is okay. For every element, the complement is in the sigma in this subset. Yes, because this is complement of not set and that one is complement of these. The complement property is okay. About 3. Yes, every member you consider and after that you gonna to union of them also is set 1 and 2. Although the third property is hold, therefore that is sigma algebra. Notice, if your subset is the power set of omega, always that is sigma algebra, and that is a larger possible of sigma algebra. In here, the previous one, this set was exactly power set of omega, therefore that was the sigma algebra. What about the question 2? If you consider your omega, in probability we show it with S or sample space, and that is your subset. You consider that is sigma algebra or not. Omega and the complement of that not set is in our collection of sets. The set A is in here, but also the complement of this set, exactly this one also. Okay, but the countable union of these all sets also that is 1 and also 1, 2, 3 properties hold. Therefore, the F is sigma algebra. What about the question 3? You consider your omega is 1, 2, 3, 4 and your capital F is just not set and the omega. Yes, because the omega is in F, therefore the property 1 hold, and also the complement of omega also not set hold the property 2. The union of two sets is omega also the property of 3 hold, therefore that is sigma algebra. Another notice, what is the smallest sigma algebra? Yes, you consider your sample space is omega, also the smallest sigma algebra is just contain not set and omega. In here we have A, B, C and our subset is set A, B, C and not set. Yes, omega is but property 1 hold, but about 2. If the set of A belong to F, we know by property 2 the complement of A, exactly B and C in a set must be belong to F, but it's not, therefore is not sigma algebra, but the properties derive from sigma algebra. Also, we know if we gonna to our collection be sigma algebra, we must be three properties. Omega belong to that, it's close to countable union, and also the complement belong to our collection. But these properties derive from the previous three properties. If you consider A1, A2, and although, and so on, belong to our sigma algebra, intersection of I from 1 to infinity, A sub I, also belong to sigma algebra. Why? Because you consider an is in our sigma algebra. We know the an complement also in sigma algebra by property 2, and the union of that also is in sigma algebra by property 3, and also after that the complement of this set also belong to sigma algebra, and these two sets are the same. But about the property 2, if A and B belong to sigma algebra, then A minus B is in sigma algebra also. Why? Because we can write instead of A minus B, difference two sets, we can write A intersection of B complement. If you consider B is in sigma algebra, B complement is in sigma algebra, and by property 1 also A intersection of B complement also is in sigma algebra. Therefore, these two sets difference is in sigma algebra. But another important thing, what is between algebra and sigma algebra, guys? This algebra has 1, 2 property, but is not close to countable union. Yes, for finite union of AI is okay, but the sigma algebra not only for 1, second property, and third property is close to countable union of member. I have a challenge for you. Do you find any sets that is algebra but it's not sigma algebra? Please let me your answer in the comment. Thank you for watching this video. Please subscribe this channel. I'll see you in the next video. Take care. Bye bye.